Listen to the conversation between the woman and the man and answer the questions. First, you have some time to look at questions 1 to 6. You should answer the questions as you listen because you will not hear the recording a second time. Listen carefully and answer questions 1 to 6.
Thank you for calling Millennium Office Supplies. If you would like to place an order, please press 1. Your call has been placed in a queue. A customer service operator will be with you shortly. Gina speaking. How can I help you?
Oh, hello. I'd like to order some stationery, please.
And who am I speaking to?
John Carter.
Right. Can I just confirm your account number and the name of your company, John?
Sure. The account number is 692411.
692411. Right. And you're from Rainbow Computers?
No, the company is Rainbow Communications.
Oh, OK. I'll just fix that on the system. Communications. And what would you like to order, John?
Envelopes. We need a box of A4, that is, normal size envelopes.
White, yellow or manila?
We'll have the plain white, please. But the ones with the little windows.
OK. 1 box, A4, white. Just the 1 box, was it?
On second thoughts, make that 2 boxes. We go through heaps of envelopes. As a matter of interest, are they made from recycled paper?
No, you can't get white recycled paper. The recycled ones are grey, and they're more expensive, actually.
Right, we'll stick to white then.
Something else, John?
Yes, we need some coloured photocopy paper. What colours do you have?
We've got purple, light blue, blue, light green, whatever you want, pretty much. There are 500 sheets to the pack.
Right, let's see. We're going to need a lot of blue paper for our new price lists. So can you give us 10 packs, please? Make sure it's the light blue, though.
10 packs of the light blue.
The woman asks the man if he needs anything else. Look at questions 8 to 10. Now listen to their conversation and answer questions 8 to 10.
Anything else that we can help you with?
Let me think. What else do we need? I'm sure there was something else.
Pens, paper clips, fax paper, computer supplies, office furniture?
Oh yes, we need floppy disks. Do you have those nice coloured ones?
Yes, but they're a bit more expensive than the black ones.
Oh, that's all right. I'm not paying anyway.
Right. Floppy disks. And what about diaries for next year? We've got them in stock already and it's a good idea to order early.
No, I think we're all right for diaries. But something we do need is one of those big wall calendars. You know, one that shows the whole year at a glance. Do you stock those?
We certainly do.
OK, can you include a wall calendar then, with the other stuff? Just make sure it's got the whole year on the one side.
Sure. And do you have a copy of our new catalogue?
No, I don't, but could you send one?
Yes, I'll pop one in with the order. You'll find it a lot easier to remember what you need if you have our catalogue in front of you next time.
Yes, good idea. And when can you deliver this?
Should be with you tomorrow morning.
Can you make sure that it's not after 11:30 a.m? because I have to go out at 12. There's only myself here on Fridays.
Fine. I'll make a note on the delivery docket that they should deliver before 11:30. Thanks very much.
Thanks.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2. You'll hear 2 university students discussing experiments. First, you have some time to look at questions 11 to 15. Now, listen carefully and answer questions 11 to 15.
Hi, Al. Sorry to interrupt you when you're having your lunch, but I wanted to ask you a favour.
Oh, sure, no problem. Sit down, Josie. I've finished anyway. What do you need?
Well, I was wondering if I could ask you about the experiments we were talking about in the seminar the other day with Dr. Robinson. I'm doing my teaching practice on Thursday and Friday, and I'm a bit concerned about it. I wasn't entirely sure I understood them completely. If I don't understand them, then the pupils don't have any chance.
You mean the ones to determine the speed of sound?
Yes, that's right. Well, I think I understood the first one, but the second one was more complicated.
Yes, that's true. Well, let's check what you thought of the first one, the one that you'll have to take the kids outside for.
OK, let me see. Well, you need to get 2 groups to stand exactly 200 metres apart on the playing fields, and one has a bell or a loudspeaker or some other loud sound source and a flag, and the other group has a stopwatch.
Yes, although it doesn't have to be 200 meters. It's just that it makes the experiment easier the more distance between them. It depends on the space available.
Right. And the idea is that one group raises the flag at exactly the same moment as they make a noise, and the other group starts the stopwatch when they see the flag and stops it when they hear the noise.
That's it.
And then you get them to do a simple calculation of velocity equals time divided by distance.
Yeah, it's a bit low-tech and it's not very accurate, but they should be able to get within about 20% of the actual figure if they're reasonably careful.
Before you hear the rest of the talk, you have some time to look at questions 16 to 20. Now listen and answer questions 16 to 20.
OK, so I understand that. It's the other one, the one with the tube I was having a few problems with. Can you just talk me through that and tell me exactly what I have to explain to the pupils?
Okay. Well, the thing to remember is that sound is a wave, and waves have both frequency and wavelength. You should start them off with exploring waves in water, and that'll introduce a few key concepts. Sound waves aren't exactly the same because they're compression waves, but it's more or less the same principle, at least for pupils at this level.
I've got some ideas for that. So they understand wavelength and frequency, and then we move on to the experiment. For that we need, let me just have a look at my notes. A long tube, a tuning fork, and a large barrel of water. Now, what do they do with those? And what's the point of it?
It's fairly simple, really. You just have to remember that velocity equals wavelength times frequency.
Ah, yes, that's the key, isn't it?
Yes, The tuning fork is manufactured to produce a sound of a given frequency, so that just leaves you one thing to measure. The pupils hit the tuning fork so that it makes a sound and hold it toward the end of the long open tube. That makes the air vibrate. They should slowly move the tube up and down. They'll find that in some positions it gets louder. That's because of resonance.
What's that again?
It's when there are a whole number of waves in the column of air in the tube. It makes it louder. They then measure the length of the column of air, and they can work out the wavelength from that.
And that's more accurate than the other experiment?
Well, it is if the pupils take an average using different tuning forks. It should be much more accurate.
Thanks, Al. That's clear to me now. I can't think of any more problems.
Just make sure that the pupils keep good records. You need to tell them how important that is. Any mistakes with the maths can be corrected later, but you don't want them to have to go back and get the data again. You probably wouldn't have time for that anyway.
Good advice, yes. I just hope it goes well in the classroom now.
Good luck.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3.
Part 3.
You'll hear a conversation among two students and their tutor about the presentation they are going to make at the tutorial class.
First, you have some time to look at questions 21 to 26. Now listen carefully and answer questions 21 to 26.
Right, Jason and Karen. How are your presentations for the next tutorial class?
I feel a bit nervous. I haven't done that before. Although many of my classmates in the same tutorial group have finished theirs. But I think them a little uninteresting because they just read out their notes. I hope mine will be more attractive.
It seems you have a higher demand for yourself. As for me, I have no sense of uneasiness because I made one last semester. But I feel no sense of satisfaction about it. It lacked strong arguments, I think. How much did you get for the last presentation, Jason? 83% actually, but my goal for the next one is over 87%. It's pretty good. What is your topic for this one? Strategies for reading. I feel my biggest problem is in the reading speed, rather than vocabulary, which is most students' problem, though. I am slow, especially in reading articles on my major courses. They are complex and dull. Have you found any effective methods? Well, I am not quite sure. I suppose to skim the books or articles is a good approach. Yes, by skimming the book first, you get the choicest parts. It saves a lot of time. You don't have to read every word of the passage, but you have to learn to read certain parts intensively. Yes, I include that in my presentation. There is one thing I'm not clear yet. Why don't we make presentations more related to our major? Once you learn to write clearly, read analytically, and listen to lectures effectively, you'll begin professional tutorials. That means you should start from the basics. Well, Karen, how is your presentation?
Before you hear the rest of the talk, you have some time to look at questions 27 to 30. Now listen and answer questions 27 to 30.
Oh, Karen, how is your presentation?
I am still in a panic. I want to find some more interesting topics about writing, but I wonder what articles I can refer to, because there are so many of them.
Did you get the list of the reading materials handed out last class?
Yes, but there are over 20 on it. I have only a week to prepare, so I wonder if
Okay,
you can...
let me give you some suggestions. You needn't read them all because some of them deal with the same issue. The article by Halsworth is really worth reading. It covers the aspects of organising the thoughts and ideas.
Okay, Halsworth.
You should also read the article by Jackson, but just look at the part on research methodology, how they did it.
Right, I'll read that one.
You should also read the article by Fisher, but just look at the part on the writing plan. That is, how to plan your writing in a systematical way.
Okay, Fisher, got that.
And if you have time, the one by Risewell says very relevant things. It teaches how to title your articles and make it appealing. You should finish the whole book.
Okay.
Now, the one by Burns, if I were you, I wouldn't bother with the whole passage. Just read the conclusion, which summarises the use of rhetoric.
Oh, now I understand. Thank you very much.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4.
You will hear a lecturer talking about food preservation. First, you have some time to look at questions 31 to 37. Now listen carefully and answer questions 31 to 37.
In today's lecture, I'd like to look at the topic of food preservation and start by asking the obvious question, why do we need to preserve food? Well, apart from keeping it fresh for our daily needs, many foods, such as fruit and vegetables, are only available at certain times of the year, so if we want to be able to eat these foods all year round, we need to preserve them. We also need to preserve food for export overseas to make sure that it doesn't perish in transit. And lastly, we need to be able to preserve food for when there are food shortages. There are a number of methods of preserving food which involve both high and low temperatures, chemicals, irradiation, and drying. Let's have a look at these in turn. In the 1870s, the French scientist Louis Pasteur showed that microorganisms in food could be destroyed by raising the temperature of the food, a process now known as pasteurization. This involves heating milk to just 65 degrees Celsius for 30 minutes. A new method, the ultra-high temperature, or UHT process, involves heating milk to 150 degrees Celsius for 3 seconds. The advantage of treating milk in this way is that it lasts much longer, though I tend to feel, and I'm sure many of you would agree, that taste is somewhat sacrificed in the UHT process. Tin cans were first used in the early 1800s to store and preserve food. Just as they are now, the cans were tin-plated steel containers, and the process had the advantage of being cost-effective. Unfortunately, however, there were many early cases of food poisoning because the canning process was not fully understood at that stage. We now know the exact temperature and length of time each food needs for proper preservation, which has greatly reduced the risk of food poisoning. People living in cold climates often preserve food by burying it in the snow, and the Romans knew all about the advantages of packing food in ice. But for most people, this was not an option until the invention of the refrigerator in 1834. Today, however, refrigeration is the most important means of preserving food because the food stays fresh without needing to be treated. However, refrigeration requires an electricity supply, and unfortunately, if the power goes off, so does the food. A variety of chemicals can be added to food, and you'll find their names listed on the labels of cans and bottles. Salt is probably the oldest of all the chemical preservatives and was used by many ancient civilizations for many years. Sugar also acts as a preservative and is used to preserve jams in much the same way that vinegar is used to pickle foods. Chemical preservatives are effective, but they do not suit all foods, and the processes involved are time-consuming. Another method of preserving food is by drying it. Most foods are 75% to 90% water, so if you remove the water, the microorganisms simply can't survive. When food is dried, it not only lasts a long time, but it also becomes much lighter, which is a big advantage, as this makes it cheap to store. Though some people argue that valuable nutrients are lost in the process.
In the second part, the speaker describes the process of drying food. Look at questions 38 to 40. Now listen carefully and label the diagram.
Early methods for drying food involved cutting it into strips and hanging it in the sun or over fires. But there are now a number of more modern methods which involve the use of recent technology. One of these is known as roller drying, and it's a highly effective way of making dried foods from liquids, such as soup. Have a look at this diagram to see how it works. Well, first of all, the hot soup is poured in at one end here. The liquid spreads to form a thin layer on a heated belt. The liquid dries as it moves along. By the time it reaches the end of the belt, all the water has evaporated, leaving only dry powder. A blade then scrapes the dried material off the roller and captures it in powder form. All you have to do is add boiling water, and you have your hot soup back again, ready to drink. Another method is called freeze drying, and for those of you who still remain...
That is the end of part 4.
You now have half a minute to check your answers.